You've got a mag drive pump installed in your chemical system. Sealless design, no mechanical shaft seal, supposed to be leak-free, low maintenance, the reliable choice for corrosive chemistry. And then it fails. Maybe it was 6 weeks in, maybe 6 months. Either way, you're pulling it out, ordering a replacement, and wondering what went wrong. James Riggins, with LibertyCES, has been specifying chemical pump systems for over 30 years. And I can tell you that McDrive pump failures are almost never a product quality problem. They are a specification problem. The wrong technology for the duty cycle, wrong materials for the chemistry, or missing protection that should have been there from day one. Today I'm going to walk you through exactly how mag drive pumps fail, what causes each failure mode, and how to spec one correctly the first time so you're not back in this conversation in 6 months. Before we talk about failure, let's make sure we're working from the same understanding of how these pumps actually function. A conventional centrifugal pump has a shaft that passes through the pump housing. That shaft needs a seal, a mechanical seal, to prevent the fluid inside from escaping around the rotating shaft. That seal is a wear component. It degrades. In aggressive chemistry, it degrades fast. A mag drive pump eliminates the shaft penetration entirely. On the outside, you have a drive magnet spinning on the motor shaft. Inside, behind a containment shell, you have a driven magnet attached to the impeller. The outer magnet spins, the magnetic field passes through the barrier, and the inner magnet rotates. No shaft, no seal. But the trade-off is the impeller is supported by internal bushings in the fluid, and those bushings have one critical vulnerability. This is the #1 cause of McDrive pump failure in chemical service. Those carbon bushings are lubricated and cooled by the fluid being pumped. The moment the fluid is gone, even briefly, they run dry. Heat builds, surfaces score, they break down fast. I've seen failures in under 5 minutes. You end up with carbon powder inside the pump, a damaged shaft, and total loss of performance. Root causes: empty suction tank, closed suction valve, or startup before priming. The fix is simple. Install a thermal flow switch like the Flowline FT10. It detects loss of flow and shuts the pump down instantly. Every mag drive system should have this. No exceptions. This one is subtle. The motor runs, current looks normal, but there's no flow. The magnetic coupling has broken. The outer magnet spins, the inner magnet stops. This happens when torque, demand exceeds coupling strength. Main causes: higher than expected viscosity or excessive back pressure. If you spec based on water but run polymer, caustic or slurry, you can exceed limits. Proper sizing based on real fluid properties prevents this. Chemical resistance depends on concentration and temperature. Polypropylene works for many chemicals at ambient temps, but fails above 180 degree Celsius. At higher temps, it loses stability and begins to deform. PVDF handles up to 220 degrees and performs better in aggressive chemistries. For hypochlorite or oxidizers, PVDF is the correct choice. For extreme duty, ETF-E-line systems provide even higher resistance and durability. Avoid 316 stainless steel in chlorinated systems. Chlorides cause stress corrosion cracking. It may look fine until it suddenly fails. Use PVDF or ETF-E-lined materials instead. Every centrifugal pump requires minimum suction pressure to avoid cavitation. When pressure drops too low, vapor bubbles form and collapse violently inside the pump. This causes noise, vibration, and gradual impeller damage. It often goes unnoticed until performance drops significantly. Always ensure NPSH available exceeds NPSH required with margin. Account for temperature and friction losses. Ignoring these leads directly to cavitation damage. The DB series is designed for flooded suction and offers high efficiency. But if suction is lost, it cannot recover and risks dry run failure. The SP series is self-priming and can handle lift conditions. Use it when flooded suction isn't guaranteed. For high head systems, multi-stage options apply. For large systems, ANSI retrofit models allow easy integration without civil changes. MUG drive pump failures come down to 4 issues: dry run, decoupling, wrong materials, and cavitation. Every one of these is preventable with proper specification. If you're dealing with recurring failures or designing a new system, reach out. You'll speak directly with someone who understands these systems and how to get them right the first time.